Raise your hand if you've heard of the scientist Isaac Newton. Anyone heard of them? Yeah, physics, father of physics. So today we're going to talk about just some ways that he observed the world. So Isaac Newton, he was a scientist that lived a long time ago in the 1600s. And all he did really is observe the world around him. So he observed how things move and how they change. And he came up with the laws of motion. So today we're going to get into the very, very, very basics of that. So talking about how things move, to simplify it, he basically was talking about force, like, so the force that you put on something, and then motion, how does it move? So our unit is all about force and motion today. I'm sure some of your parents are scientists or engineers at home, and they probably have a lot of good information or maybe some good activities you can do because maybe they use physics at work, or maybe they've done a lot of physics work in school. So I'm going to go ahead and screen share right now. And I'm going to ask that you just kind of follow along. And I will ask you guys to type some responses to questions into the chat. And just so you know, I can't see your faces right now. I can only see the slide. So, all right, piece of cake. We got this, guys. All right, so force and motion. So our learning target today, this is our big thing that I want you to be able to do. I know it's pretty simple. All I want you to be able to do is explain what a force is and explain what motion is, and then identify examples of each. So, and I'm going to ask that you please don't draw on the screen or anything like that while we're sharing, okay? So what is a force? So a force is a push or a pull on an object. So thinking about Isaac Newton, like I said, he looked at how objects behave, how things move. So if you look around in front of you, you probably have some different things on your desk right now, maybe a pencil, maybe some paper, maybe a glass of water. We'll consider those all objects, even your body, an object. So he was saying an object is going to stay at rest. So whatever it is, an object's going to stay at rest, whether it's your pencil, your cup, your body, it's going to stay at rest until a push or a pull sets it in motion. So when we're talking about a push or a pull, that's the force that we're talking about. So if you take a look at the picture down here in the left-hand corner, there's a little slide and a ball. So in the chat, so we have our object, which is our ball, and it's going to stay at rest. It's going to stay right where it is until a force acts upon it. So in the chat, can you type what force would move this ball? So type something that might move that ball. Someone said wind, good. A push, air. Yeah, so if wind is gonna be moving it, or air, we'd say it's probably pushing it. Oh, good, gravity. Good, yeah, a kid might come up and push it. You might push it, yeah. Good. A foot, yeah, someone might climb up there and give it a kick. Yeah, a young kid. Good, yeah, so lots of different things could act on this object. So let's say that someone did climb up there and then they pushed it down. They used a force. What we would say the cause, or why, you say maybe the ball rolls down the slide, and we would answer, is it a push or a pull? And most of you guys were talking about pushes. So kind of going through this little 3-step method, this is what we're going to be doing to go through this. So what's causing it? What's the force? The ball is going to roll down the slide. It's a push. And then the effect, you know, it rolls down the slide. So let's take a look at this one. There's like this awkward kid on a skateboard. And I would like you to think, is he, so the cause or the force, the boy pressed against the ground with his foot. So think about, maybe some of you guys are skateboard riders. He's going to press against the ground with his foot. That's our cause. Pressing against the ground, would you say that's a push or a pull? Go ahead, type it into the chat. When he's moving with his foot. Good. A lot of you guys are saying push, and I saw someone type in friction. So I'm going to switch over to the chat for a second so I can see your faces. Can anyone raise their hand and tell me what is friction? Maybe Jamie was the one that said that. What is friction? Because friction is not the push really that we're talking about. Jamie, do you know how to unmute yourself?
Yeah.
All right, go for it. What is friction?
Friction is when like two things rub together.
Yeah, two things rub together, and what is friction going to cause that skateboarder to do, for example?
He could stop.
Yeah, stop, slow down. Good. So friction definitely helps change those forces, right? It's going to slow them down. So back over here, the cause, he's going to press against the ground. It's a push. And then the effect is that he's going to glide down the road, right? And friction plays a part. Like if it's a really bumpy road, there's going to be a lot of friction. But if he was riding like maybe at a skate park that has really smooth ground, there's not going to be a lot of friction. He's going to be able to slide really nicely. All right, let's go into another one, playing Tug of War. So thinking about playing Tug of War, the Y or the force, the children are pulling the rope in opposite directions. That's what's happening. What do we say? That's a push or a pull in Tug of War? Go ahead, type it into the chat. Good. Some of you guys had your answers ready to rock. Good. So when you're playing Tug of War, both kids are trying to pull. If you were to push on the rope, that would give the other side an advantage. So in Tug of War, both sides are pulling. So in the middle, we would just say pull. And then the effect would be that the children who pull the hardest, of course, pull the rope towards them. And I saw someone mention gravity in here. And I'll switch back over to the group. Who can tell me what role is gravity playing in this Tug of War or any of these examples? Raise your hand if you want to kind of expand on that. Let's see, Chloe down here.
Me?
Yes.
A gravity would have an effect on that because if you pull one way, there will be an effect on the other side. Like
So
gravity would cause to pull or push back.
So gravity is the force that's doing what to everything on the
Pulling
earth?
down.
Pulling
on
down.
The earth.
So it's pulling down. So if someone were to let go of the rope onto the other side, right, what's going to happen?
Gravity's going to pull them down at an angle.
Yeah, gravity's going to pull them down. But if they were playing Tug of War in space,
there'd be no gravity to pull them down.
Yeah, it'd be a whole different ball game. Good. So let's check over to this. So again, the Y, what's happening? The kids are pulling. It's a push or pull. It's a pull, and then the effect is whoever pulls the hardest is going to get the rope on your side. Let's see, Gage, did you have a question? If you could unmute yourself.
When you talked about doing it in space, there would also, if you were close to the planet, there'd be a gravitational pull from the sun and the planet. And then if you were near to another planet or a large object, you would still be attracted to it. So wouldn't there be a tiny bit of like gravity? And then isn't there also a vacuum? So that could also be something. Like,
good questions. We may have to pull your dad in here to help answer some of these. But yeah, so in space there is always gravity. Those objects are pulling. Everything is pulling on something, right? But as you kind of get out of the Earth's atmosphere, you're not getting pulled down to the Earth, but you could get kind of stuck in the gravitational pull of things. All right, those of you in the chat, let's stop typing for a little bit. We're going to keep going. All right, so playing Seesaw. All right, what do you guys think of this? Push, pull, both on a seesaw. Okay, what's happening? Why the force? Children are kind of going up and down on the seesaw. What do you guys think? Push, pull, both. Good. I see some of you saying push, some of you saying both. I think I'm going to go with both because the last time I rode a seesaw, kind of rocking back and forth, pulling with my body back, pushing up with my legs, pulling back when I go down. So I'd say both for this one. And of course the effect, you guys go up and down. All right, if you have your student packet in front of you, you should be able to just fill this out now. Lesson 1 is pretty simple.
What if you already did it?
If you already did it, awesome. You might want to just check it right now. So it says at the top, our learning target, I can explain what force and motion are and identify examples of both. Your important words are force and motion, and we'll have those definitions at the end. Roderick, please stop typing that. All right, so let's go over here. Again, our cause, the why, the force, what's happening. This is kind of a terrible example. I probably should have changed this, but say this kid is trying to move a washing machine, which I hope none of you do. But the boy is pulling the washing machine. Is it a push or a pull, or both? A pull. And the effect, the washing machine will move toward the boy. Okay, probably not. Maybe imagine it's a box, but this is how we're going to fill it out. So let's look at the second example. There's a kid riding a bike. Hope lots of you guys have been outside riding your bikes. All right, what could we type in this first part? What is happening? What could we say? The boy is doing what? Type it into the chat if you got that response ready. What is the boy doing? I may have to block some of you guys if you're being silly. Yeah, so in this first part, the cause, you could just say the boy is pedaling. Yeah, the boy is pushing on the pedals. So riding a bike, would that be a push, pull, or both? You would say push. And what is the effect, or what is the motion? Of course, when you're pedaling your bike, you're going to move forward. So you can fill that part in right now. Again, the first part, what's happening, like what's the cause? The boy is pedaling on his bike. In the middle, you would write push, and then the effect is he's moving forward. All right, so let's look at the second one. So vacuuming. Maybe you guys have been home helping your parents keep it clean at the house. So you've been using a vacuum cleaner, hopefully. All right, so what's the cause here? When you're using a vacuum cleaner, you're gonna push it back and forth. In the middle, we would say push, pull, or both. You would say both. And then the effect would be, yeah, I would definitely say both. So you would push and pull it back and forth. So you're not necessarily talking about like the dirt that it's sucking up. You're talking about, you know, how the vacuum cleaner is moving. So the effect would be that the vacuum cleaner moves back and forth over the floor. All right, whoever is typing on the screen, please stop. We're gonna keep going. All right, so the next one, we'll just do a few more examples and then we're gonna just review at the end. All right, so right here, there's kicking a soccer ball. So the cause is the girl is pushing the ball with her feet. Right here, if you're kicking a soccer ball, is that a push, pull, or both? And this one I feel like is tricky, but they're saying she's kicking it, because with a soccer ball, you could push it or pull it with your foot. But if you're kicking it, we would say that's a push. And then the effect would be that the soccer ball is moving away from the girl. Good. All right, let's look at the next one, dunking a basketball. So the cause right here, and this is not in your packet, it was only the first page. So right here, the first one, we would say the cause, the girl is pushing the ball into the basket. So think of yourself shooting that ball into the basket. Is that a push, pull, or both? We would say a push. And then the effect would be that, you know, the ball goes through the basket. Okay. All right, good. Some of you are saying both. Does anyone want to expand on that? If you're dunking it into the basket, so maybe not necessarily bouncing the ball. See a lot of you guys saying both. Let's see. Can anyone maybe say a little bit more for us? Who said both? Let's see, Ryan. Why did you say both?
I said both because you're pushing the ball into the hoop, but
Mhm.
you're also pulling the ball to get to the hoop instead of like pushing it forward. You're like pulling it in so you don't before you dunk it in so it doesn't fall.
Okay, maybe you're thinking of like a slam dunk, slamming it in. Okay, okay, I could see that. All right, anyone else want to expand on that? Okay. All right, let's do one more. Swinging on a swing. Right here for the cause, we would say the girl's pushing her body forward and back. So swinging, we would say is what? Oh, lots of good responses in the chat. Yeah, swinging is both, right? And the effect would be that the girl is going to swing back and forth. Good. So again, pushes or pulls, these seem really simple, but this is the basics of physics, like how things move based on a push or a pull. All right, so if you have your packet in front of you, up in the right-hand corner, it says important words. One of them is force. So a force is a push or a pull on an object, causing it to move, stop, or change directions. Motion is just moving, right? Changing location from one place to another. So go ahead and fill those in. Right now, if you haven't done so already, this is that page in your force and motion packet.
Which page is it?
Let me switch back over to my screen. All right, so it's this packet right here. And if you turn to this page, this is the one that we were just working on. We did examples down here, and right up here, important words, force and motion. So you should be filling these out right there.
Miss Salter?
Yes.
Are we supposed to do the bottom where it says force, push, pull, or both?
Yes.
On the
That's,
very bottom?
yeah, we just went over that one together.
Yeah, okay.
All right, good question, John. All right, so I'm gonna go back to screen sharing.
Miss Salter?
And Broderick, I may have to block you if you can't stop chatting in there, okay? So going back to force and motion. So again, a force is a push or a pull on an object, causing it to move, stop, or change direction. And then motion, really just moving, right? Changing a location from one place to another. All right. So that is the end of our lesson. It's pretty simple this week. We're going to get into Newton's 3 laws of motion next week. As a 5th grader, you don't need to have these laws of motion memorized, but you do need to be familiar with them and how objects move. So understanding push, pull as a force, that's the foundation of what we're going to be getting into.